Hello and welcome back. In this example, we're going to work through finding the equation of a line in space, a vector equation, that passes through 2 points, P0 and P1. So, keep in mind that for any line, we can express it R of t. Our vector equation looks like some fixed vector that points to some fixed point on the line, plus some multiple of the direction vector. So the direction vector v is any, this is any vector parallel to the line. And really any vector will work because we're considering all scalar multiples of it. So how do I get this direction vector? As I showed you in the example in the earlier video, one choice for v could be P0, P1. That gives me a vector between those 2 points, which will necessarily be parallel to L. So I'm going to set v equal to P0, P1. That'll always work. As long as I have 2 points on the line, I can set my direction vector to be the vector between the 2 points. And so let's see, what is P0, P1? It has to go 3 in the x direction, 0 in the y direction, and down 5. And so that works for a direction vector, which means my equation, my vector equation of the line will look like, what's my R0? It's just 1, 2, 4. And so this will look like 1, 2, 4 plus any multiple, so t times 3, 0, negative 5. And then I should say where t is between negative infinity and infinity, because I'm considering the whole line here. So, oops, I don't want a comma there. Sorry. So we let t take any value because we want the line to go off to infinity. We want the entire line there. Now you might wonder, what if we don't want the entire line? What if I just want a line segment from P0 to P1? So what if I just want just the part of the line that's between these 2 points? Well, I get line segments by changing the domain of my parameter. So change domain of parameter so that the left bound, if I put the left bound in for t, I get R0. And if I put the right bound in for t, I get R1. Or rather, I get the head at P1. And so how can I do this? Well, if I put in t equals 0, I get out R0. So I'm actually going to call this R1, just for illustrative purposes. R1 is going to be 4, 2, negative 1. That's my R1. So R0 is the same as R of 0. Right? That's not by definition or anything. That's just noting if I plug 0 in for t, I just get 1, 2, 4, which is R0. So R0 of t, R0 is a specific vector, not a function. So R0 is R of 0. So if I put 0 in for t, I get 1, 2, 4. And now I want to find what parameter. So that tells me my left bound. That means I want t to start at 0. And I'm going to do less than or equal to because I actually want it to start at 0. So less than or equal to. And then what do I pick for my right bound? What value of t gives me R1 when I plug it in for R? Well, the way we laid this out, if I put 1 in for t, then I'll get R0 plus my direction vector v. I should get exactly R1. So let's just evaluate. Let's just check R of 1. So here's my vector equation. So this would be 1, 2, 4 plus 1 times 3, 0, negative 5. Adding these together, this gives me 4, 2, negative 1, which is R1. So that means when t is 1, my vector R points at P1. So if I want to start at P0 and end at P1, I should end my parameter at 1. So t between 0 and 1 with this equation. So I would say So we would say r of t equal to 1, 2, 4 plus t times 3, 0, negative 5. And then I'll say here where t goes between 0 and 1. This gives me the line segment from P0 to P1. And notice there's a direction to these things, right? As t increases, I'm moving along the line from P0 to P1. I'll let you think about what if you want to go from P1 to P0. How do you get a vector equation that goes in that direction? So that's a special part about these vector equations is they actually have direction to them, which is going to be very important to us later when we want to talk about motion in space, when things are actually moving and there's some notion of direction. Okay, that's it for this video. I hope it was helpful. I'll see you next time.